Today, we're going to dive into a clinical sign that's super subtle but incredibly powerful. It's visible right there on the surface of the neck, and it's called the jugular venous pulse, or JVP for short. It's like a direct window into the heart, and we're about to see exactly how.
At first glance, it might just look like a faint little flutter, but it is packed with crucial information. So what story is this one tiny pulse in your neck actually telling us about the complex machine that is your heart? Well, let's find out. The JVP is often called a window to the heart, and honestly, it's for a really good reason. It gives us this amazing, non-invasive, real-time view of the pressure changes that are happening inside the right side of the heart with every single beat. So what is it, officially? Well, the JVP is the visible pulsation you see that reflects pressure changes happening way down in the heart's right atrium. These phasic changes are really just the rhythmic rise and fall of pressure with each heartbeat. This makes the JVP a fantastic stand-in for what we call central venous pressure, a super important indicator of how your heart is doing and your body's overall fluid status.
So you might be asking, why the neck, of all places? It's because the internal jugular vein, or IJV, has this straight, uninterrupted line directly to the right atrium. You can almost think of it as a fluid-filled pipe that perfectly transmits the heart's pressure waves right up to the surface. It's the perfect spot to watch what's going on. But here's where it gets really interesting. This isn't just a simple one-note up-and-down pulse. Oh no. The JVP has a really complex shape, a waveform, that tells an incredibly detailed story about the entire cardiac cycle. Just take a look at the shape of this waveform. You see, unlike that single, strong pulse you'd feel in an artery, the JVP is biphasic. That means it has two distinct peaks for every single beat of the heart. And each one of those peaks and valleys corresponds to a very specific event inside the heart. And each one of those peaks and valleys corresponds to a very specific event inside the heart.
Let's break this whole thing down. First up, you have the A wave. That's the atria contracting, pushing blood down into the ventricle. Right after that, the tiny C wave happens. That's just the tricuspid valve bulging back a bit as the ventricle squeezes. Then comes the X descent, as the atrium relaxes. Next, the V wave rises, as that same atrium passively fills up with blood. And finally, you get the Y descent when the tricuspid valve swings open again, letting all that blood rush into the ventricle. It's the entire story of one heartbeat, right there in one little wave.
Now here's something that trips a lot of people up. A really crucial skill for any clinician is learning how to tell the difference between the subtle JVP and the big, booming carotid artery pulse right next to it. At first glance, they might look similar, but they are worlds apart.
So what's the biggest giveaway?
Well, you can see the JVP, but you can't really feel it. It's this soft, fluttering wave that actually disappears if you press lightly at the base of the neck. The carotid pulse, on the other hand, that's a strong, single thrust that you can easily feel, and it's not going anywhere. Plus, the JVP changes when you breathe or sit up, while the carotid pulse couldn't care less.
All right, so now we know what to look for and how to tell it apart from the carotid pulse. But how do we actually measure the JVP in a clinical setting? Let's just walk through the process step by step. The whole thing really boils down to 4 key steps. First, and this is everything, positioning. You have to get the patient comfortably reclined at a 45-degree angle. Next, you carefully watch the neck for that gentle pulsation. Once you've got it, you find its highest point. And finally, you measure the vertical distance from that highest point straight down to the sternal angle, that little bony notch where your ribs meet your breastbone.
And I can't stress this enough. That 45-degree angle is absolutely crucial. It's not just a suggestion. It positions the top of that fluid column perfectly, so it can be seen and measured accurately right there in the neck, relative to the heart. Any other angle, and you're going to get a misleading measurement.
Okay, so we've gone through all this trouble. Why? What does this measurement actually tell us? Well, the JVP provides some really critical diagnostic clues about a patient's health. This is where it all comes together. Before we can talk about what's wrong, we need to know what's right. So, in a healthy person, the JVP should measure somewhere between 6 and 9 centimeters of water. That range tells us that the pressure inside the right atrium is normal and healthy. The magic number to remember is 9. If you get a measurement over 9 centimeters of water, that's considered elevated. That's abnormal. It's a clear red flag that the pressure on the right side of the heart is too high. So what could be causing all that extra pressure?
Well, an elevated JVP is a classic sign of some pretty serious conditions. We're talking about things like right-sided heart failure, congestive heart failure, or even a physical blockage in a major blood vessel like the superior vena cava. In these cases, the JVP is often one of the earliest and most telling clues a doctor has.
And this quote just captures it perfectly. It's a simple observation you can make right at the bedside. You don't need any complex equipment. Just careful observation gives a clinician a direct window into the pressures inside the heart. It's an amazing testament to the power of fundamental clinical skills.
And that really leaves us with a final thought, doesn't it? If a simple, visible pulse in the neck can reveal so much about our most vital organ, what other subtle but powerful clues might we be overlooking in our everyday observations? It's just a reminder to always, always look closer.